Let's start by finishing the video that we ended with last time.
You're much more likely to see a total lunar eclipse in your lifetime. They can last an hour and 40 minutes, and they're viewable for anyone on the night side of Earth. During a total lunar eclipse, the moon often turns red. If we didn't have an atmosphere, the moon would go completely dark, but the gas molecules in our air scatter the shorter, bluer wavelengths of light, while the longer, redder wavelengths pass through to the moon. Or to put it another way, during a total lunar eclipse, the sun projects all of the world's sunsets and all of the world's sunrises onto the moon at the same time.
A lunar eclipse is when the moon falls into Earth's shadow. So if we have the sun back behind you again, it's the projector in this case, we have Earth, just like the moon was casting a shadow before, Earth is also going to cast a shadow. And if the moon travels into Earth's shadow, it will be covered up from reflecting any light. Because the moon does not produce its own, it only reflects light. So as the moon travels into Earth's shadow, the moon is going to start to get darker and darker. That is known as a lunar eclipse. Why lunar? It's the moon that's being covered up. A solar eclipse was when the sun was being covered. A lunar eclipse is when the moon is being covered. These are going to be much more common. And I want you to think about it this way. We have Earth, and this is where everybody lives, except for the 7 or so that are on the space station right now. As the moon is traveling this way, the moon will travel into Earth's shadow. That means that every single person on this side of the Earth can see the moon. Every single person that's on the nighttime side of the Earth will be able to see a lunar eclipse. As opposed to when it was a solar eclipse and you had the path of totality travel across the surface of Earth, only the people that were in that little tiny shadow could see that solar eclipse. The Earth is much bigger, casts a bigger shadow. The entire moon is going to be in the shadow, which means if you are living on Earth and you are looking at the moon, every single person in the nighttime side of Earth will be able to see that lunar eclipse. Another thing that I want to point out, we're going to get to moon phases next, but because the moon only reflects light, we are only seeing the half of the moon that the sun is shining on. Right now, the sun is behind you. There's always half of the moon lit up. Whether the moon is here, 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 half of the moon that's facing the sun is going to be lit up. To see the entire face of the moon has to be right behind Earth. Remember, we are on Earth looking at the moon. So we have to be between the sun and the moon, looking at the moon, in order to see the entire face of the moon. In order for there to be a lunar eclipse, you have to have the entire face of the moon showing. We call that a full moon. This is going to be difficult for you to visualize sitting in that camera that you guys are. If we are on planet Earth and we are looking out at the moon, as the moon crosses in front of the sun, this back half is lit up. The front half is actually the dark side of the moon. This is the half that's lit up because the sun is over there. So if we are on Earth, we do not see this lit up side of the moon. We only see the dark side. When we only see the dark side, we don't actually see the moon. It's dark. We call that a new moon. In order to have a solar eclipse where the moon is covering the sun, this is the lit up side of the moon, we have to have a new moon. In order to have a lunar eclipse, we have to have a full moon. A lunar eclipse does not have quite the same impact that a solar eclipse does. A solar eclipse, the sun goes away, the temperature falls, nocturnal animals will come out. A lunar eclipse, the moon turns color. The moon goes away a little bit. It does get a little bit darker, but you have to basically use a light meter to detect that. Then the moon's going to turn red. We'll get to that in a moment. And then the moon turns back into its normal self. It's not like the sun disappears. So it's not quite as impactful as as a solar eclipse. And because every single person on this side of the Earth can see it, half the world's population can see that lunar eclipse. People see lunar eclipses much more often than solar eclipses. It's not that they happen more often, it's that more people can see them when they do. So you're more likely to see a lunar eclipse than a solar eclipse. Up here is a picture of a full lunar eclipse. And you might think, well, if a total solar eclipse makes the sun disappear, why does that not make the moon disappear? The reason is because as the moon is traveling behind planet Earth, yes, the moon is in shadow. However, and this is important, we have a little tiny layer of atmosphere on our planet. And as sunlight travels into our atmosphere, it's going to get scattered. It's known as Rayleigh scattering. It's why the sky is blue. It's why sunsets are orange. It's why the moon looks red. What's happening? The moon is here. Normally, we wouldn't be able to see it because the sunlight hitting it is blocked. But what happens is all of the sunlight that is traveling through our atmosphere is actually bent onto the moon. The only sunlight that can hit the surface of the moon is light that is traveling through our atmosphere. And when it travels through our atmosphere for a long time, it turns red. That's why sunsets, where the sun is traveling through a lot of our atmosphere, looks red. Sunrises, they look reddish orange because the sun is traveling through our atmosphere and the shorter blue wavelengths get scattered out. Only the longer red wavelengths make it through. So what we are actually seeing when we see a full lunar eclipse is the entire world's sunsets and sunrises being projected onto the surface of the moon at the same time. As the moon gets covered up and we don't see direct sunlight bouncing off of it, then it is dark enough to see that faint red glow of all of our sunrises and sunsets reflecting off of the moon. This is the color of every Earth sunrise and every Earth sunset put together. During a lunar eclipse, what's happening? The only source of light in our solar system is shining light on Earth. Half Earth is going to be lit up. That's daytime, nighttime. Half of the moon is going to be lit up. Full moon, we can't see this dark half. Because Earth is blocking sunlight, it's actually casting what we would call an umbra, just like with a solar eclipse. The moon is going to travel around in its orbit into first the penumbra, where part of the sunlight is being blocked. You can see that Earth is blocking part of the sunlight. So the moon will start to get a little bit darker. And then it will travel into the umbra, where it blocks all of the sunlight except for those sunsets and sunrises. Then it will travel into the penumbra on the other side, and then back out of Earth's shadow, and it will be a normal brightness moon. While it's in the penumbra, because some actual sunlight is still hitting the moon, and it's able to be reflected back to Earth, it's very difficult to sense any difference. The drop in brightness is very small, because there is still sunlight hitting it, reflecting back to Earth for us to see. In section 2 the other day, you guys sketched a solar eclipse. What I would like you guys to do for section 3 is sketch a lunar eclipse. I want you guys to have the sun, the Earth, the moon, label the umbra and the penumbra. We had different types of solar eclipses. We had an annular solar eclipse, where you could still see the ring around the outside. A total solar eclipse, where the entire surface of the sun is covered and you can finally see the chromosphere, you can see some prominences, you can see the corona. We had a partial solar eclipse, when we're in the penumbra and part of the sun is blocked. There's also different types of lunar eclipses. Sunlight is coming in this direction, daytime, nighttime. Lit up side of the moon, not lit up side of the moon. As the moon travels around in its orbit, it is going to travel into different parts of Earth's shadow. So you can have it half in the penumbra, half in the umbra. That's a partial lunar eclipse. If it's all the way in the umbra, it's total lunar eclipse. If it's all in the penumbra, it's known as a penumbral eclipse. And if it's not in the Earth's shadow at all, it's an unclipsed moon. This is a total lunar eclipse. You can see the shadow of Earth. Earth is round. This is time lapse. This is many different photos all stitched together. The moon is slowly traveling behind Earth. Still some sunlight, so we don't see the red yet. But as soon as all of the moon is covered up, now we're seeing those sunrises and sunsets reflecting back off of the surface of the moon. If we were on the moon looking at planet Earth, this is what we would see. We have the surface of the moon, which would be visible because of sunlight bouncing off of it. As we look at Earth covering up the sun, we would see a solar eclipse because it's the sun that's being blocked. And then all of the sunlight would travel through the atmosphere. It would bounce back red on the surface of the moon. A partial lunar eclipse is where the moon will travel partially into the Earth's shadow, and this is on repeat. You can see that the Earth's shadow starts to cover the moon up, starts to create it being dark. A lot of people mistake this for it being a phase of the moon. The difference is that phases of the moon take weeks to occur. This only takes a couple hours. And finally, the penumbral eclipse. This is when it is partially in the moon's shadow. So there is still a little bit of the sunlight hitting off the surface back to Earth. You guys see the difference? Unless you knew this was happening, nobody would even know that this eclipse is going on. You can tell that there is a slight difference between light and dark, between uneclipsed and penumbral eclipse. But unless you knew this was happening, it'd be very difficult to see.
If you looked at the moon over the course of a few weeks, you'd probably notice that it looks slightly different every day. The change in its shadow is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle. Overall, the whole process lasts only from a few minutes to a few hours, so you'll have to be quick if you want to see it. But, as long as you're willing to stay awake, you'll catch the moon as you won't see it too often.
So let's take an overview of what we've learned the last couple days. The only source of light in our solar system, the sun, is shining on the moon and the Earth. Half of the moon is always lit up. Half of the Earth is always lit up, daytime, nighttime. Here, this is a solar eclipse because the moon is blocking sunlight. Here's the umbra, the path of totality. This would be a total solar eclipse, partial solar eclipse. In order for this to happen, the dark half of the moon has to be facing Earth. So as we look at the moon, we are seeing the dark half. We call that a new moon. As the moon orbits, maybe it's going to cross through that plane of the ecliptic, and everybody that's on the nighttime side of the Earth is going to see this lunar eclipse. Only the people here are going to see the solar eclipse, a small fraction of the Earth's population. Everybody over here can see the lunar eclipse.